This is a geometry lesson for chapter 1.5, basic perimeter and area formulas. These are formulas from your past, stuff that I'm hoping that 7th, 8th grade math, maybe even algebra, that you've seen these formulas before. So I'm going to do it in kind of a quicker fashion. I'm not going to be as in-depth as I might in other sections, but this should go in your notes, and we're going to teach this lesson via video. So first of all, we have figures, we have a picture, and a perimeter and area formula. So obviously we know what a rectangle looks like. We'll draw our rectangle and little tick marks on congruent parts. So rectangles have right angles in the corners, and they have sides across from each other that are the same, so I put those markings on it. Our perimeter, for any time the sides are straight, I just have one perimeter formula, and it's add all sides. Area formula, usually we either have a length and a width or a base and a height. It does not matter which variables you use. If you want to use a B and an H or an L and a W. Our area formula, we're going to take the base, we're going to multiply it by the height. Square. We have a perfectly shaped quadrilateral with 4 right angles, 4 congruent sides. Sometimes they list the sides as an S, and they have the area formula to be side squared. Because a square is also a rectangle, I often just use a B and an H. You can really use either formula and use area is equal to base times height. The base and height are the same, so I see both formulas quite a bit. Again, because the sides are straight, we add all sides for the perimeter. Perimeter is around the outside. Area is if I colored it in. So hopefully you've seen those two terms before. Triangle is next. So I have a triangle. And on a triangle, in order to do the area, you have to have a height somewhere. So I'm going to dot in the height, and the height has to come down as a right angle. And we have a height and we have a base. Again, all the sides are straight, so we add all sides. And then we have the area of a triangle. And for area of a triangle, we take the base and the height and divide it by 2. Or a lot of times I'll write 1/2 BH. Or if you want to use area is equal to base times height divided by 2, we'd have the formula. And the last thing is a circle. A circle has a radius. I'm going to call that the R. R is the radius. Here the sides are curved, so we have to use a different formula for the perimeter. And for a circle, the perimeter has a word that is associated with it, and it's circumference. Circumference has a formula, and it's 2 pi r. And we will find a pi button on our calculator when we go through this. That's for around the outside of the circle. For the area of the circle, how much is inside? I hope you've seen this formula before. It's pi r squared. So I'm going to use these formulas to do some very general problems here, some very not overly complicated, but problems you should be aware of. In this class, we have numerical problems where the answer is a number like 5. And then we have expression problems where the answer will have an x in it or some type of variable in it. And I have 2 different types, okay? So first of all, a rectangle, a numerical problem. The area of this rectangle, well, I have a base and I have a height. I take base times height. Base is 8, height is 4. The area is 8 times 4, or 32. For perimeter, I add up all the sides. 8, 4, 8, 4. So 8 plus 4 plus 8 plus 4. And out of that, I get 12 plus 12, or 24. That's a numerical one. The answers came out to be perfect numbers. A problem with variables. let's do the area. Okay? Well, area is always the base times the height, and I have x plus 3 there, so this would also be x plus 3, and this would also be 2x for a rectangle. But back to the problem. I'm going to do the base times the height, and the base I have as x plus 3, and the height I have as 2x. So I have an x plus 3 and a 2x. And what I really have to do here in order to find the areas, I have to simplify this expression. So I'm going to go ahead and I'm going to distribute that 2x back through. Take 2x times x and I get 2x squared. And I take 2x times 3 and I get 6x. So the area is the expression 2x squared plus 6x. And this is common for geometry, where you have these variables in here and you come up with an answer like that. Perimeter. Add up all the sides. 2x plus x plus 3 plus 2x plus x plus 3 for a grand total of 2x, 3x, 4, 5, 6. Looks like I have 6 x's. And then I have a 3 and a 3, which makes 6. Let's see, 2, 3, 4, 5, 6 x's plus 6. Perimeter is another expression. Square. Perimeter. Or let's do area first like we have been. Area is add all sides or sides squared. So square, these are all 12. 12 times 12 is 144. Perimeter, add all sides. Or sometimes I also see 4s, or 4 times number of sides, because all these are 12. So I could do 4 times 12, or I could do 12 plus 12 plus 12 plus 12, which is 48. So I do either one of those two. The harder one, area. Okay, problem with variables. The sides are x plus 5, so I take the length times the width, or the base times the height, or this is actually the same as x plus 5 squared, or side squared. So all of these things are really kind of similar. And then what I'm going to do here is I'm going to distribute and simplify and combine like terms. So if I simplify two binomials times each other, well, I use the acronym FOIL. And I'm going to have to FOIL this guy out. So let's do that. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. So I did first, outside, inside, last, for a grand total of x squared plus 10x plus 25 is the area. And again, it's an expression that we write as our final answer. For perimeter, I'm going to write this in kind of a funny way, just because, one, because I have the room for it, but two, sometimes when you write addition of these things, add up all the sides, I can write them vertically. X plus 5 plus x plus 5 plus x plus 5 plus x plus 5. My perimeter grand total is 4x plus 20. And that would be the perimeter. Again, an expression for your answer. All right, let's keep going. Numerical problem. It's a triangle. Area of a triangle is 1/2 the base times the height. Well, I have all these numbers here. I have to be able to pick out a base and a height. There's my base. The height comes down at a right angle. So I'm literally going to take 1/2 of 5 times 3.5. I'm going to go ahead and use my calculator. I'm going to go with 0.5, which is 1/2, times 5 times 3.5. I did that, and I got 8.75. It's the area. The perimeter. The perimeter is add up all sides. 3 plus 4 plus 5, 9 plus 3. I got 12 for the perimeter. Add up all the sides. All right, a problem with variables. Let's do the area. Area is 1/2 the base, x plus 3, times the height, x minus 1. Okay, I have the half there. I'm actually going to leave that half there. I'm not really going to do anything with it right now. I guess I could. There's other ways to proceed, but I'm going to leave that as I FOIL that. Leave that alone, FOIL that. So here we go. I got x squared is x times x. That's minus 1x. That's plus 3x. And that's minus 3. So I got 1/2 of x squared. These two right here make 2x minus 3. I got 1/2 of x squared plus 1/2 times 2 is x minus 1/2 times -3 is -3/2. And really what I did there in that final step is I went ahead, after I FOILed it and combined like terms, I went ahead and took the 1/2 and I distributed through the parentheses. And I got that for my area. All right, last thing is the perimeter. I'm going to write it vertically again. I liked that last time. So I'm going to take x squared, I'm going to add to it 5x, and I'm going to add to that x plus 3. Only some of it will go together. The 3 doesn't really have anything combined with it. The 5x and the x go together, but the x squared won't add with those two. So 5x plus 1x is 6x. And then I have the x squared attached onto the beginning. Looks like I have x squared, I have 6x, and I have plus 3 for the perimeter. Again, I don't use any specialty perimeter formulas. When the sides are straight, I just know it's going to be add up all the sides. And we have it. All right, last two, numerical problem. I have an area. Area for a circle is pi r squared. Pi, radius is 6 squared. And 6 squared is 36. And then I still have the pi there. And really that 36 pi is the area. Now, pi is a weird number. It's a decimal that goes on forever and ever, 3.1415 with a whole bunch of decimals. So a lot of times what we do in math is we just leave the pi there because we don't want to use that big, long, funky decimal. So 36 pi is a legitimate answer that will appear on a lot of these quizzes. I'm also going to put approximately what it is by using a calculator. And right up over here, you might notice on those calculators there is a pi button. And I don't ever use 3.14. I use 36, and then I'm going to put times that pi button. So it's going to look like that on my calculator, 36 pi. I hit enter, and I got 113.097, approximately 113.097 is the area. Okay, and I got my 8. My perimeter. My perimeter also has a formula. The perimeter formula is 2 pi r. 2 pi. The radius is 6. 2 pi r, 2 pi 6. 2 times 6 is 12, so I got 12 pi. That is an answer that is legitimate. 12 pi might appear as one of the answers on the Canvas quiz. Do not be shocked. Do not always look for the decimal. So I'm going to crank it out now. 12 pi. Turns out you don't even have to hit the multiply sign. You can just type it in like that, 12 pi. And I got 37.699. I'm just going to put 37.7 approximately. 37.7. Okay, and that would be the perimeter. And I haven't been putting any labels on there. If there's labels, you might have to add it like 37.7 inches if this was in inches, and this might be 113.097 square inches, depends on the problem, but we'll go from there. All right, this one, area, pi r squared, 5x minus 3 squared. Pi r squared. I have a parenthesis squared. I'm going to need the FOIL once again. 5x minus 3 times 5x minus 3. And I really challenge you here to hit pause in this video and go ahead and see if you can FOIL that out. hopefully you've unpaused. Pi, I'm going to FOIL. 5x times 5x is 25x squared. 5x minus 3 is minus 15x. That's another minus 15x. And that's plus 9. Negative 3 times negative 3 is positive 9. I get pi, and I get 25x squared minus 30x plus 9. And to be honest with you, I would probably leave it like that. I guess we could take the pi through, but it really doesn't help us simplify anything, and it doesn't do anything to it. So I'd get an area answer that looks like that big thing right there. Pi 25x squared minus x plus 9. Perimeter. This one, I can't add all the sides because it's curvy. So I use the 2 pi r formula. 2 pi, the radius is 5x minus 3. I guess I would probably leave the pi and distribute the 2 through. So I'd probably leave the pi there and take the 2 through. This isn't the only way I could have done it, but this is just a way. So that'd be 10x minus 6. I guess I could write it as 10 pi x minus 6 pi if I wanted. There's some other things I could have done with it, but I would have written that for the perimeter for that problem. Okay. Last thing that you have to be able to do in this section is work backwards. Working backwards means they'll give you the area or they'll give you the perimeter, and you have to back up to find maybe the length or the width, depending on the problem. So I'm going to do a few of those examples, and then we'll be done with our notes. So it says the area of a rectangle is 108. Area is 108. It tells me it's a rectangle. I could draw a rectangle. It tells me one side is 12. And I don't know the other side. I could put a question mark, I could put an X, a lot of things I could put there. So my area is base times height, and literally what I do is I go through the problem and I start plugging things into that formula after I write it down. So 108 goes there, 12 goes for one of the sides, and I don't know the other side. So I'm going to put 108 is equal to 12, and I guess I'll use a variable x. I'm going to let x be what I don't know. I put a question mark there, but I'm going to put an x there. So I'll put an x there, I'll divide by 12, and my x value is 108 divided by 12. I'm pretty sure that's even. I think it's 9. 108 divided by 12. Yep, I got 9. So my other side is 9. And it, again, this one didn't give me a thing. I should probably be putting like units or units squared, but I'll just put a 9 there, 9 units. The base of a triangle is 6. The area is 57. Find the height. Let's draw a picture. The base of a triangle is 6. The area is 57. Let's find the height. All right. Area is equal to 1/2 base times height. 1/2. The base is 6. The height is, I don't know. I could leave it an h. I could put an x. Okay, I'm going to go ahead and also plug that 57 in for the a. And I have an algebra 1 equation that I can solve. Okay? What I would do here is I would multiply these together and get 3. Half of 6 is 3, and I got 57. And I'm going to divide 57 by 3. 57 divided by 3, and I got an x value of 19. And again, I could put 19 units. I could put 19 a lot of things, but I'm just going to put in 19 there. The area of a circle is 144. Find the radius of the circle. Okay, I don't know the r. I could put it as an x or an r, whatever I want to put it, and it tells me the area. So the area for a circle is pi r squared. My area of 144 goes in for the a. And I got to solve it out for the r. Okay, what I would do to get the r by itself, I'm going to divide by pi. And I got r squared is equal to, I'm going to go ahead and figure out what 144 divided by pi is. And I got 45.83. And I hope at this point you're not hitting clear on these calculators. So I got that big long decimal there, and what I want to do is I want to use that decimal in the next problem. So one thing you can do, well, let's go back and do the math here first. I got r squared. I hope you know from Algebra 1, to get rid of a squared, you square root. But one thing I can do on these things is I can carry a problem. So the square root key is like right there. So I'm going to hit second function key, square root, and it will bring in the square root. And then what I can do is I can use these arrows to go up to that problem, and I can hit enter, and it will actually bring that big long decimal down to the next. And I use these little arrows here to cursor up, and that is a very accurate answer that way, and I can get a very good approximation of what the R is. So my R value is 6.77, and I should put approximately 6.77 for my radius. All right, last problem here. The circumference of a circle is 144. Find the diameter. Ooh, a little bit different. So this time they're telling me circumference is 144. It wants to know not the radius, that's the R, it would like to know what that diameter is. So if I find the radius, I just double it to get the diameter. All right, 2 pi r for circumference, that's the formula from the previous page. 144, 2 pi r. I need to go in and I need to find the r by dividing by 2 pi. Really common calculator error is to go 144 divided by 2 pi. 2 pi. If you do it like this, it will crank out the wrong answer. That is not correct, because what it does is 144 divided by 2, and then it multiplies that answer by pi. You either need to do it like this, with parentheses to get the right answer, or you need to use the fraction button on your calculator to get the right answer. Okay, either one of those two methods would be preferable. There you go, you can kind of see it there. So 144 divided by 2 pi, I got 22.918. I'm going to leave that answer on my calculator, and I'm going to multiply it by 2 because the diameter is double the radius. So the diameter is going to end up being that 22.9 times 2, but I'm going to leave that up on my calculator, times 2, and I got a diameter of 45.836, 45.84 diameter. Again, I should probably put like units or units squared, but I'm going to leave it like that. So. All right, hopefully you've seen some of these formulas before. A lot of times what we do in geometry is we add these variables in or make you work backwards. So I hope you can use this video if you need to go back and look at something as just as a reference to help you with this section. All right, thanks.